Hey all, welcome to Homeschool and welcome back to Class 11 Physics series. See, in my previous videos, we have discussed everything about motion in a straight line and also two other chapters we have discussed in physics. And today, I am starting with a very interesting chapter, motion in a plane. If you can observe a chapter, motion in a straight line, you have noticed an object moving in only one direction. Either object it is horizontally moving, or the object can move vertically upwards, vertically downwards, horizontally right, horizontally left, whatever. But object was moved in only one dimension, that is in one direction. Right? So if an object moved in one dimension, how you can represent it, how you can describe the motion with the help of velocity, acceleration and various forms of graphs, all that we have discussed. And every time object doesn't move in only one dimension, you'll have many instances where the object can move in two directions. Okay, say the object can move something like this, and again from there it may come, it can move in two dimension, or it can move in three dimension. If you can observe a circular motion of object moving in a circular path, it's like object moving in three dimensions, right? So circular path. Say like that, you have many instances that you will observe the object moving in two dimension, or in other words, we say object moving in a plane. So let us understand every concept that helps to describe an object moving in a plane. But to study this particular concept, we need to take the help of some mathematical tool called vectors. So vectors is a very beautiful concept which makes our life easier, especially in case of physics, I can say. Okay, so with the knowledge of vectors, you can clearly solve many questions of physics. I mean, the use of vectors is vast, not only for this concept, it can be used for many other concepts that you study in physics. So first and foremost, we need to understand this concept of vectors. So there are many aspects to know about these vectors. So let us first discuss about the vectors. So I may take two videos to complete all the concepts of vectors. So this video and my next video, do not forget to watch. Definitely you will get strong basics in the concept of vectors. Okay, fine. So coming to physical quantities. We all know many physical quantities that can help in describing a particular object, right? So the moment I say physical quantities, can you able to give some examples? Yes, definitely. Anybody can do this, right? Say physical quantities like mass, temperature, pressure, right? Velocity, displacement, force, many are there. All these are physical quantities. So these physical quantities are used to describe an object. So they are very much essential in case of studying, scientific laws or scientific concepts. Okay, so how do you represent a physical quantity? We always represent any physical quantity with some number, then some units, right? Number with some units. For example, mass of this particular chalk piece is around 50, right? So 50 what? 50 grams. So this is a number. I can say this is a magnitude. This number, in other words, we can call it as magnitude. Magnitude means it is the amount. Okay, so how much is the mass of this particular chalk piece? It is 50 and the units, gram. This is how we can represent any physical quantity. Okay, but there are some physical quantities where to understand them, this particular knowledge is not enough. Okay, for example, force. So you have something called force, right? Okay, so I have an object here and I applied 5 Newton force, on this. Okay, say when you apply 5 Newton force, definitely the object will move, right? But you know what? If I just tell the force is about 5 newtons I applied on this object and it moved, is it a complete information about a situation? No, right? So information is not complete. If you can say in what direction you have applied a force, then it is complete. Isn't it? So you must say, oh, I applied 5 Newton force in this direction, so the object moved, something like this towards the right. So if you apply a force in this direction, the object will move downwards, right? So here, just mentioning the magnitude and unit is not enough for a physical quantity. Okay, so it becomes incomplete if you just represent a physical quantity with just magnitude and unit. Okay, so you want something called direction here. So knowing an information about direction is also very, very important. Okay, so for which all the physical quantities direction plays a major role? It is force and velocity, right? Acceleration, then you have displacement, etc. Right? So for these physical quantities, just mentioning a magnitude, that is a number with a unit, is not enough. It doesn't give a complete information about a quantity. Okay, so if you can mention a direction, your answer will become perfect. Direction is very, very important, guys. You can't neglect the direction. Why? Because I'll tell you one example here, right? This is your house. Okay, imagine this is your house, and you have a road from along your house, and you know what? This is the circle. You had got some circle there, and here the road got split. Okay, so this is one road. This is first road, second road, third road, and this is your fourth road. Okay, and your mom tells you to bring 1 kg of chocolates. Okay, so you started your journey here, and she tells that the shop is there near a circle. Just go to the circle and bring 1 kg chocolates. This is what your mother told. Okay, so this is the path to go to a circle, right? And you will go, and here you will get a confusion whether to go in which direction. Your mother told to get 1 kg chocolates from the shop which is there near a circle, right? Which is there near a circle. Okay, say she did not give a complete information there. Okay, so there are 3 directions from a circle. Where is the shop exactly? Is the shop there here or here or here? Right? Say you will go first and there is no shop, you will come back. You will go like this, there is no shop, you will come back. Actually, the chocolate shop is here. You must go straight. Okay, but the moment you come here, you will get struck. You will get struck that to which direction you must go. Okay, so if you could know the direction, if your mom told go straight from a circle, you get a shop, get 1 kg chocolates, when she could tell the direction, then it has a complete meaning, right? You just imagine how important directions are to know, right? So if you were knowing the direction here easily without wasting your time, you would go straight, you'll go to a shop, you'll get a chocolates, and you will come back, right? So this is how the direction plays a very, very important role. Okay, say the force you applied onto the object. Okay, so 5 newtons is the force you applied, but in which direction you have applied, yeah? That's very important, right? Definitely when you apply a force, the object moves, but in which direction you have applied and in which direction the object is moving. That's very important to know. Okay, similarly, say you have a car. Okay, so this car is moving with a velocity of around 50 meter per second. 50 meter per second. Okay, say this is not enough. This information is not enough. Okay, the car is there, velocity 50 meter per second, but in which direction the car is moving? Is it going forward or is it moving backward? Right? You must be aware of the direction. Right? So there are certain physical quantities where direction plays a major role. Okay, you need to represent them with magnitude, units, and extra one thing is there, that is direction. Right? And such physical quantities are called vectors. So vectors are very simple, guys. Vectors are those physical quantities which have both magnitude and direction. Okay, so what are the examples for vector? Force is an example for vector, acceleration is an example for vector, velocity is an example for vector, displacement is an example for vector, and there are many examples. But these are some important examples that you are studying in your class 11 physics. Okay, and similarly you have some physical quantities, we call them with the name scalars. Scalars in the sense we don't care about the direction. There is no issue of direction at all. Only magnitude is important. They are represented or described with the help of magnitude only. Say the mass of this chalk piece is 50 gram. Say I can hold the chalk piece in this direction, or it may be here, or it may be like this, or it may be like this. I don't care about the direction. When I hold a chalk piece something like this, I'll get 50 grams. If I hold a chalk piece like this, 50. If I hold it, 50. If I hold down, then also 50. So there's no issue to think about a direction here. So these physical quantities, temperature, mass, pressure, distance, all of them are described only with the help of magnitude. Okay, there is no issues of direction in describing those physical quantities. So such physical quantities are called scalars, right? So hope you understood what is the difference between a scalar quantity and a vector quantity. Now let us write the points in a meaningful way. So now let's define scalar quantity and vector quantity properly. Scalar quantity is that quantity, that physical quantity which has only magnitude, okay, which has only magnitude, right? And now coming to a vector quantity. Vector quantity is that physical quantity which has both magnitude and direction. So this is the definition you must have studied even in your school level, right? Say we studied this vectors and scalars from class 9 onwards. I mean, you just have exposed to these words. You might not have studied in depth, okay, but you have exposed to these words. So this is how we can define scalar quantity and vector quantity. But you are in class 9, you have to update your definition for vector quantity. Okay, say vector is the one which has to have magnitude, direction, and also the physical quantity that must obey laws of vector addition. Laws of vector addition. Okay, so there is a law called triangle law of vector addition. So we have something called triangle law of vector addition. Okay, so that particular law has to be obeyed by a physical quantity. Okay, when a quantity can satisfy having magnitude, direction, and when it can obey triangle law of vector addition, then it is called as a vector quantity. Okay, so this is what the important definition that you need to remember about vectors. Okay, so what are the examples for vectors here? As I told you, velocity is a vector, right? And acceleration is a vector. Displacement, which can be represented as S, right? So S here means displacement is a vector, and most importantly, force is a vector, right? And what examples you will give here? Mass is an example, temperature is an example, pressure is an example, distance is an example, right? Speed is an example. So all of them are scalar quantities. Fine. So let us study more aspects of vectors now. We got to know what exactly we mean by vectors, right? Okay. See, in physics, all our velocity, acceleration, they have to be described with some direction. So when you have to do some mathematical calculations, knowing a knowledge of vector plays a very, very major role, right? Okay. So now let us understand how to represent a vector. So representation of vector we are going to learn. Representation of vector, right? See, vector is always represented as just arrow. So what do we call it as? Arrow, right? So arrow. And this part of a arrow is called, tail part. And this part of a arrow is called head part. So much easy. No need to get confused here. So this is our tail part. This is our head part. So vector is just an arrow. Vector means it's an arrow. So that's a way of representing a vector. Okay, say for example, velocity is a vector, right? Velocity, I'll call velocity as velocity vector. Okay, so how do I represent velocity vector? We write the symbol V and then above the symbol arrow. So this says that velocity vector. Instead of writing a word velocity vector, you can just use this symbol. It means velocity vector. Okay, so to tell something as vector, what do? On a symbol of that quantity, we just write an arrow. Okay, so the moment I write this, it is confirmed that it is a vector quantity. It's a velocity vector. Okay, or we can represent vector as symbol only. We can write it as a bold. In your textbook, you will find this. Okay, so bold V, bold, thick V when I write, it means that vector. Okay, but you will get confused. Just normal symbol for velocity is V. Bold V, if you write, you are telling that velocity along with the direction. Okay, so you will tend to get confused, right? So better you use this representation for vectors. Okay, say for example force. Okay, force is a vector quantity. For force vector, how do you represent? What is the symbol for force? F. So above the symbol, just an arrow. So this is force vector, right? And the other way, for example, displacement is there. Another example, it is displacement, right? So symbol S, on this I'll write arrow. So that is the way of representing vectors. So this is velocity vector, this is force vector, and this is displacement vector. Okay, so arrow vector is nothing but an arrow. Wherever you have an arrow, I'm talking about the vectors. Okay, so that means some physical quantity which I am describing with both magnitude and direction. Okay, so this is how we normally represent vectors. Okay, fine. Now let us understand about representation of magnitude of a vector. This is also very, very important to understand, guys. Representation of magnitude of vector. Magnitude of vector. Okay, say for example, force. Okay, we know force is a vector, right? We know force is a vector. So as a vector, we can write as F and above that one arrow. And if you want to mention only magnitude, okay, so then it can be represented as mod F or just the symbol F. Okay, so this is how we represent the magnitude of a vector. Magnitude of a vector is represented as mod F vector or just writing a symbol F. Okay, so you may be wondering what is this magnitude, all that, right? Say for example, so I have a value force, okay, or let me take this lively example. So there is an object, okay, so to this object I am applying force in this direction, that is about 5 Newton. Okay, so how do I represent that? F arrow is equal to 5 Newton. Okay, so this is magnitude. This is what? This much is what? Magnitude. So this number itself we will call it as magnitude. And this is not enough. I have to mention direction also, right? So what is the direction? Right side. I am applying force onto a right side. Okay, see, when I apply a force, the object is moving where? Onto a right side. So onto a right side, I have applied the force. So this is complete information of telling about this force, right? So vector, force is a vector. Force vector is equal to, how much is the magnitude? 5 Newton. And direction also definitely you have to mention, then only it becomes a vector. Okay, so what is the direction? Direction is right side. Okay, I applied force something like this and the object moved right side. So this is what the complete information. For example, I don't want to mention this particular direction. I just want to mention, what? Only the magnitude. Then I will write it as like this. Okay, so magnitude of force, it means that this symbol means magnitude of force is just 5 Newton. Okay, or instead of writing this mod F, I can also write just F. I can just write as F. Okay, so just F when I write or mod F when I write, it means that I am only talking about the magnitude. Okay, so but when I write F bar, I mean this we can also call it as bar. Okay, so when I write something like this, you know how you have to mention magnitude, you should mention, and you must also mention the direction. Okay, so when I just write mod F or just F, okay, without any arrow, if there is no arrow upon, then I am just talking about magnitude. Okay, so this is how we represent magnitude of a vector. Okay, say for example velocity vector. For velocity vector, how do you mention only magnitude? We will just write something like this, or we can just write V. Okay, or for the displacement vector, how do you represent its magnitude? This is displacement vector. Only magnitude if I want to represent, I can write something like this, or I can also write just S. Okay, so which is easy? Writing mod is easy or writing just the symbol is easy? So writing just the symbol is easy, right? So when I write just the symbol, it means that, say, when I write just F is equal to 5 Newton, I'm only talking about magnitude. But when I write F bar, F arrow is equal to 5 Newton, F arrow is equal to 5 Newton, and in the bracket, or you know what, I have to mention direction also. So usually we don't write like this, right side, left side, this way in the form of words we don't write. Actually direction is represented with the help of unit vector. Okay, so that unit vector we will study now. Okay, so usually we don't write the word right side or left side. This is replaced by one of the symbol which we will call it as unit vector. Okay, so let's have a small introduction on these unit vectors now. See guys, unit vector is very important to understand. Listen carefully. I'm giving you a slight introduction on unit vector in this video. In my next video, we will talk about this in a detailed way. So just try to understand this. Unit vector is a vector. Okay, it is a vector which has magnitude 1. Which has a magnitude 1. Okay, and what is the use of this unit vector? This is mainly used to represent only direction. Only direction. Okay, say you would be wondering what exactly we mean by this. Just observe. Say, as I took this example from starting, let me take this only. Say 5 newtons of force I applied in this direction and the object is moving right side. Okay, say if I have to represent a force vector here, F arrow is equal to, this is the magnitude. Okay, this much is the force I applied, and to which direction the object is moving, or in which direction I have applied the force. I applied onto a right side. Okay, say I just told you that we will not be writing direction like this, right, left, up, down, these words we don't use. Instead of that, we can use unit vector to represent the direction. Okay, so that is the use of unit vector. So unit vector's magnitude is 1. Magnitude is 1. So when you multiply unit vector for this value will not change, because unit vector's magnitude is 1. Okay, so normally unit vector is represented, if n is a unit vector, it is represented with the help of this symbol. We call it as cap. Okay, n cap is unit vector symbol. Okay, say here, instead of writing right side, what I will write here is F cap. Okay, so what is F cap here? What is this F cap? Unit vector. Unit vector. Okay, so actually this is a force vector. Unit vector is a small vector which is hidden here. Okay, and it doesn't have anything to do with magnitude. It only tells about the direction. Okay, so to represent the direction, unit vector is used. That's what you will have to understand basically. Okay, for example, you see there is a car with velocity, it's moving 3 meter per second, in forward direction. It's moving, car is moving right side with 3 meters per second. So how do you represent velocity vector? V bar is equal to 3. This is the magnitude. Meter per second is the unit. Okay, and then direction. See, I don't write it as right side. I don't write car is moving right side. Right, that word I don't use. Instead of that, we write V cap. So what is V cap here? Unit vector. Okay, so this is how unit vectors are used. Okay, so usually this is a way of representing unit vector. Okay, but actually speaking, we have different types of unit vectors here. Okay, so I'm just telling you about different, in a common language we can call it as different types of unit vectors. Unit vectors. Okay, we can represent them as I cap. I cap is one unit vector, J cap is one unit vector, and K cap. These are the different types of unit vectors actually. So what do you mean by I cap, J cap and K cap? They can also be called with the name orthogonal vectors. You can also call them as orthogonal vectors. Okay, so let me tell you what is this I cap, J cap and K cap. They are also unit vectors only. See, we all know Cartesian coordinates, right? So if this is y axis, right, this is x axis, okay, then y axis is perpendicular to x axis, and then right, and this is our z axis. So if I hold, this is our y direction, this is our x direction, and what is z direction? Actually it is pointing towards you. This direction is z direction. Okay, so this is how we will show 3 coordinates, right? So you know what, it is actually coming out of the board, that to represent on a board, we will write a line like this, right? So this is our x axis, y axis, z axis. If an object is moving, or if an vector is moving in this direction, x direction, then the unit vector is represented as I cap. Okay, so if a vector is moving in y direction, okay, if a vector is moving in y direction, then the unit vector is represented as j cap. If a vector is moving in z direction, then the unit vector is represented as k cap. Okay, so if a vector is moving in negative x-axis like this, if an object or if any vector quantity's direction is like this, opposite to x-axis, then its unit vector can be represented as minus I cap. Okay, so if a vector is moving in negative y-axis, then the unit vector is minus j cap. If a vector is going in negative z-axis, then the unit vector is represented as minus k cap. Okay, so now you see how I will apply this. See, I said I applied 5 newtons of force on a x-axis. On which axis I am applying a force? Say vector is moving in which direction, guys? So vector is in x-axis. Right, so instead of writing this f cap, I can write it as I cap. Unit vector that is moving in x-axis is represented as I cap, right, like this. Or one more example, try to observe. See, I have a car. Okay, so I have a car, right, and this car is moving like this in a positive y-axis. Okay, with a velocity of around 3 meters per second. Okay, so this is a vector which is a moving, velocity is a vector, right? Its direction is like this, positive y-axis, right? So how do you represent velocity vector here? Velocity vector is equal to 3 meter per second. This is magnitude. Direction, I don't tell it as car is moving upwards. I cannot write direction as upwards. Okay, instead of that, you see, I can write with the help of unit vector. Say if a vector is moving in positive y-axis, how do you represent a unit vector? You will represent it as j cap, right? So this is the use of unit vector, right? So whenever you find these symbols I, j, k, I means what? Unit vector. Unit vector is used to describe the direction for a vector quantity. Okay, clear? So this is a magnitude vector. Has to be described. It is a product of magnitude and direction. Magnitude is this number with unit. Whereas direction, you can't write it as right side, left side, up side, bottom side. No. Okay. So for that, to represent the direction, we take the help of unit vectors. So I means if a vector is moving on positive x-axis, I cap. If it is moving on y-axis, j cap. If it is moving, on z-axis, it is k cap. Okay, so we only discuss motion in 2 dimension, means either x dimension, y dimension. Okay, so I cap and j cap is of greater use. Okay, so we normally don't use z axis. So when you go for motion in 3 dimension, then k cap has a use. Okay, but for 2 dimension motion, we only have I cap and j cap. Is that clear? So hope the concepts are getting clear for you. So this is a slight introduction about unit vectors. Okay, so more detailed aspects we will discuss in our next video. Clear? And now say unit vector is one of the type of vector. Like that you have different types of vector, like equal vectors are there, parallel vectors are there, negative vector, null vector, all of them let us try to understand one by one. See guys, the next type of vector is equal vectors. So what do you mean by equal vectors? So just observe here, this is one vector, AB vector, okay. Another vector, CD vector, okay. So AB vector, this can be written as A bar and this can be written as B bar, right? This is one vector, this is another vector. If you can see these arrows, magnitude is same, direction is also same, right? Actually their unit vectors are same. Unit vectors means magnitude 1, direction, they help in describing the direction. This vector is going in this direction, this vector is also going in the same direction. Okay na? This is having one unit vector, this is having one unit vector that represents the direction. Unit vectors are same. So anyway, let me not confuse you. Just try to understand, equal vectors are those vectors which have same magnitude and direction. Okay, so what do you mean by magnitude here? Magnitude of arrow means the length of arrow. Okay, so whenever I represent something like this and I said this is one vector, its magnitude in the sense what? Its length of that arrow. Okay, normally speaking. So two vectors which have same magnitude and direction are called as equal vectors. Okay, so now just observe this. This is your AB vector. Okay, and this is your CD vector. Okay, can you call them as equal vectors? Magnitude may be same, length may be same, AB's length may be equal to CD's length, but you see the direction? This vector is moving like this and this vector is moving something like this. Direction is different. Okay, so they are not, and these guys, I'm talking about these guys. Okay, so they are not equal vectors. They are not equal vectors. Okay, so hope you understood about equal vectors. Much simple, nothing much to deal about. Okay, fine. And the next type of vectors that you need to know is parallel vectors. Parallel vectors. So observe here, this is one vector, AB vector, okay, and this is another vector, CD vector, right? So here what is similar and what is different? I can say direction is similar, okay, right, and the direction is parallel, right? So both are parallel to each other, both are parallel to each other, okay, but they have different magnitude is different, right? So you can just observe the length of the arrow. This is quite a bigger arrow and this is a smaller arrow, right? So such vectors are called parallel vectors, okay. Next one is negative vector. Understand this carefully. This is very important and we keep using this quite often. So negative vector. See, this is our AB vector. So this is our AB vector. Okay, so let me call this as vector A, or I can also call it as AB bar. Okay, so AB vector or just A vector, right? Okay, and you see I have another vector of same magnitude but in different direction. So this is our CD vector. Okay, so I can call it as CD bar, or let me call it as B bar, B vector. Okay, so here A vector is equal to minus B vector. Okay, so here magnitude is same, length is same, but the direction is different. Okay, so A vector is equal to minus B vector. So the moment I say minus, in the sense what? The same vector, but the direction is different. Okay, so such vectors are called negative vectors. And the other vector is there, that is null vector. Null vector. So null vector, in the sense magnitude is 0. In null vector, magnitude is 0. It is usually represented as something like this, 0 vector. And here direction is not defined. Okay, so direction is not defined. Clear? So that is what we mean by null vector, right? So hope you are clear with different types of vector. So now we will learn about sliding of vector. We call something like parallel shift. Let's understand about this parallel shift, because this is very, very important to study addition laws of vector. We have triangle law of addition, parallelogram of addition. Okay, so to study the addition, to do addition of vectors, this parallel shift is very, very important to know. Let's see what is that. See guys, sliding of vectors. Okay, so slide in the sense what? Shifting, right? So we are going to shift the vectors. See here, you need to understand about parallel shift. Parallel shift. So what we actually do it here is, imagine this is a vector AB. So this is AB vector, okay, or I can call it as A vector. So this is some A vector, okay, and I can shift this vector from here to here, okay, so that its direction will not be changed. When I shift this vector parallel to this, you know, when vector is slided parallel, its direction will not change, okay. So it's like this is also AB vector only. So the same vector you can slide, you can shift its position. Okay, so you know, this is a vector, right? Imagine this is a AB vector which is there in this direction. So I can shift always parallelly. Somewhere here I can bring this. Okay, so when I bring this vector from here to here, it is the same vector. It has not become a different vector. Okay, it's not a different vector, it is the same vector. I just, as long as you slide a vector parallelly, its direction and magnitude will never change. Okay, say I can say, for example, this is some vector AB vector, right? AB vector, and I can parallelly, I can shift this vector here, right? I can also shift this vector here. So as long as I slide or shift the vector parallel somewhere else, it remains the same, right? So this shifting of vectors is much helpful concept for the addition of vectors. So you must know this concept, that whenever vector is slided parallelly, okay, say you can't shift, say the vector was this, it was here, and you can't write the same vector like this. Okay, so you can't shift this vector like this. You can only shift parallelly. Okay, so this vector you can shift it here. You can write parallelly. It remains the same. Okay, so you can slide a vector parallel to each other. I mean, they are the same only. There's no change in the direction. Okay, so you can always shift vector parallelly. Okay, even if you shift, there will not be any change. Okay, it remains the same. So this sliding of vector is a very, very important thing to understand vector additions, okay, which I deal it in the next video. Right, in the vector addition, you need to add the two vectors. You have to add in such a way that the tail of one vector must be in touch with the head of another vector. Okay, say for example, this is one vector, AB vector, okay, and this is another vector, CD vector. Say if I have to add AB vector with CD vector, I can add in such a way that the tail of this vector must be in contact with head of another vector. Okay, so what I will do, this vector I will shift like this, parallel shift I will do. So this is our CD vector. The same vector, when I shift, parallelly, it becomes like this, right? So now this is AB vector. So this is how I can add the vector. For adding vector, this parallel shift will help a lot. Okay, see, I need to add this vector with this vector. So addition must take place in such a way that tail of one vector must in touch with the head of another vector. This vector is here, this vector is here. How do I add? So I will use the parallel shift concept here. So this vector I can shift parallelly, right? So what I will do, this line I'm shifting parallelly and I'm placing like this, so that I can have a joint between this vector and this vector in such a way that head of this vector is touching with the tail of this vector. Okay, so or you can do one more thing. Say this is what is that, head of this vector, right? This is the tail of this vector. You can shift this vector like this. So this is also a parallel shift only, right? So this is AB. I'll keep AB same. I will shift CD vector parallelly. Then also, you will find like this, CD vector. So this is how I can bring two vectors closer if they are far away. I mean, if I want them to have a connection between tail of one vector and head of one vector, I can always shift one vector parallelly, so that I can bring these connections between tail of one vector and head of another vector. Right? So these things are very much useful for vector additions. So that's why parallel shift is one important thing that you need to look over. Right? So today we have discussed why vectors are necessary, what are vectors, difference between scalars and vectors we have discussed, and then very, very importantly, we learned how to represent a vector. And what do you mean by magnitude of vector, how to represent magnitude of vector, and then unit vectors, right? Equal vectors, parallel vectors, actually these vectors, the vectors which you can shift anywhere, such vectors are called as free vectors, right? So free vectors, null vectors, negative vectors, all of them we have discussed. So in my next video, I will be discussing about vector additions. There are two ways of doing vector additions. One is graphical way and the other one is analytical way. Both the ways are very important for competitive point of view, also as well as for board point of view. Okay, and after that we'll discuss about multiplication of vectors, and we have something called resolution of vectors. So all these aspects we will be discussing in our next video, and do watch that video too. Share the videos with your friends and do subscribe our channel to learn the concepts in an easiest way. Thank you so much.